So in the previous episode, I talked about electrolysis and electrochemical cells, right? So in this video, I'm going to be talking about the calculations using the mole concept. Now, these calculations, they are going to involve the what I talked about in the previous video. So if you have not watched the previous episode, before you watch this one, you can go and check it out and understand the basis of electrolysis. So and then we're going to do calculations on mole and using we still apply that electrolysis knowledge at the end of this video. Thank you for watching and please pay attention. Now, our first question will be calculate the simplest formula of a compound which has a composition magnesium 9.8%. So that's 9.8% of magnesium. Then we have 13% of oxygen, 13%. We have 26% of water, sorry, 13% of sulfur, right? Sulfur. Oxygen is 26%, 26% of oxygen. And then lastly, we have water of crystallization, 51.2%. So what that means is that we have magnesium here, we have sulfur, we have oxygen, and we have water of crystallization. So what this question is asking us, we are looking for the simplest formula. Now, in the basic fundamental videos of this series, I said the simplest formula of any compound is known as the empirical formula. So now, the first stage you do whenever you have your reacting ratios, or whenever you have your reacting masses, either reacting masses or percentage mass, you divide those masses by the respective relative atomic masses of each of the elements, or rather the elements or molecules. So now we are going to divide this. We are going to divide magnesium 9.8 by the relative atomic mass of magnesium, which is 12, which is 24. Divided by 24. For sulfur, we are going to divide by sulfur's atomic mass, which is S2. This thing, that's 32. Then we are going to divide for oxygen. We are going to divide by oxygen's relative atomic mass, which is 16. For water, we divide by water's relative molecular mass, which is 18. So now when we divide this one, we have the first for magnesium we have 0.408. For sulfur, so we express it in ratios now. Ratio for sulfur we have 1 divided by 32, we have 0.408. Ratio for oxygen we have 1.63 ratio. Then for water we have 2.84. Now after dividing by the respective relative masses of these, then you divide again by the lowest number you can see in that ratio. So for example, in all this ratio, 0.408 is the lowest. So I'll divide every ratio by that 0.408. Divide by 0.408. Divided by 0.408. Divided by 0.408. Divided by 0.408. So this will give us 1 ratio 4 ratio 7. Now the last stage of this calculation is to convert those ratios back to your compound. So for when we have Mg, we have magnesium is ratio 1, so we have one atom of magnesium. Sulfur is 1, so we have 1 atom of sulfur. Oxygen is 4, so we have 4s. And those numbers, you put them aside number 1, you put those numbers as subscript. For example, this O we have a subscript 4. That's the relative amount of atoms of oxygen. So and then we have H2O. No, let's put dot H2O. So for this H2O we have 7. So we'll put it as a coefficient 7H2O because it's specifically known as the water of crystallization. So and then the compound, the formula, the empirical formula of this compound is magnesium tetroxide 6 heptahydrate. So this means MgSO4.7H2O. So that is how you calculate the simplest or empirical formula. Just in case you don't know it from the previous videos calculation. So moving on, we have next question we're dealing with today is dealing with 0.465 gram of a hydrated form of sodium tricarbonate 4 exactly reacts with 75 centimeter cube of 0.10 molar hydrochloric acid. Calculate the number of moles of water crystallization present in one molecule of the hydrated salt. Now what this means is that 0.465 of sodium tricarbonate. So basically what that means is it's hydrated, right? So that's Na2CO3 dot. Now that's H2O. We don't know how many moles of hydrated water. So we just put X dot X H2O. So the mass of this reacting is 0.465. That's the total mass. Then it reacts with 75 centimeter cube of 0.1 molar HCl. So that means the volume of the acid is 75 centimeter cube, and also the concentration Ca is 0.10. So that's 0.10 molar. So yes, that's hydrochloric acid. That's HCl. And then we have they said calculate the number of moles of water crystallization present in 1 mole of the hydrated salt. So and then what they are asking us to look for, we are looking for X here. So and then let's start with the equation of reaction. So we have hydrochloric acid, right? It reacts with this hydrated salt. Let's write HCl plus Na2CO3. Na2CO3. Now we'll not put the XH2, the water of crystallization, because it's only the acids and base that react. So the water of crystallization does not react with them. So and then our product will be sodium chloride and NaCl plus CO2 plus H2O. So this will be in the ratio of 2:1. NaCl plus H2 and 2CO3 plus 2HCl plus 2. Yes, so this will be 2. I'm trying to balance the equation. This will be 2 and this will be 2. So the ratio of the acid to the base is 2:1. That means if we are using CAP is equal to CBP, we have Na is 2, Nb is 1. So Na ratio Nb is 2:1. Then then the number of moles of HCl in the solution will be what? So the number of moles is equal to Cv, right? N is equal to Cv. So let's say the number of moles Na we see what's concentration? That's 0.1 times the volume of the acid is 75 centimeter cube. So but whenever we are looking for moles, we have to divide by 1000 to get the volume in dm cube. 1000. That's if the volume is not in dm cube already. So and then when we do this, our answer will be 0.0075 mole. So and then we have that if the number of number of moles of the acid is 2, then the number of moles of the base will be 1. So and that is just like a ratio. So if the number of moles of the acid is 0.0075, so the number of moles of base will be that number divided by 2. So that is the conversion factor. So NB, number of moles of the base, will be 0.0075 because it's a relative number over 2. So that is the number of moles of the base in this reaction. So and then the number of moles of this base, yes, so this is, and when we calculate that will be 0.00375. That's 0.00375 mole. Now, having done that, we have the molar mass of sodium tricarbonate 4 is 106. So whenever you want to look for the mass, you are going to, the mass is equal to the number of moles times the molar mass. So that will be times 106. That means the reacting mass will be what? 0.3975. So you can see that out of that 0.465 gram that of the hydrated salt, only 0.3975 is what will react in the neutralization reaction. So and that automatically means that is the Na2CO3 out of the hydrated salt. So and that water that is not reacted will be when you subtract the 0.475. So water XH2 will be 0.465 minus 0.3975. That will give us 0.0675. So now we want to look for the relative number of moles, right? So what we'll do now is we are going to divide both the mass of the Na2CO3, and we are going to divide the mass of the H2O, both of them, by their relative molecular masses. So that means for Na2CO3 we'll divide 0.3975. We'll divide by the relative molecular mass, that's 106. Then for this one, we'll divide by the relative molecular mass, that's 18. So and then when we do that, we'll get our ratio. At the end of the day, we have a ratio of 1:1. So that means the ratio of the sodium trioxocarbonate 4 and its water of crystallization is actually 1:1. So we have 1 mole of Na2CO3, that's Na2CO3 dot H2O. That is how you solve that kind of question. Now moving on to the last question for this video, and this question is based on electrolysis. So and it says that which is based on the topic we treated in the previous series. During the electrolysis of copper 2 salt, the quantity of electricity passed was 9,650 coulombs. Calculate, number 1, the number of moles of copper metal deposited, the mass of copper deposited. So this is a very simple formula. This is a very simple question. So and then let's use the direct proportion method. So it said the quantity of electricity was 9,650. So but before we do that, we know that in electrolysis the number of electricity required to liberate it is equal to the magnitude of the charge. So that means for copper 2 plus, that means for this copper 2 plus, 1 mole, right? Yes, the 1 mole will be deposited by 2 Faraday. That's 2 times 96,500 coulomb. So because the number of Faradays is directly proportional to the charge on the ion. So for copper, which is 2 plus 2 positive, that will be 2 Faraday. Now then, if 1 mole is liberated by 2 Faraday, then how many moles will be liberated by, in this case we have 9,650. So let's call it X. So and then we cross multiply. So X will be equals to 1 mole times 9,650 divided by 2 times 96,500. So this will cancel this, will remain 10 behind. So and then when we cut everything down, at the end of the day we have the amount of moles that will be liberated is 0.05. And then now they said, what is the mass liberated? So the mass liberated is equal to the number of moles times the molar mass. So when we multiply 0.05 times 64, which is the molar mass of copper, we have what? That's 3.2 gram. So the solution of this question, when you pass 9,650 coulomb of electricity through a copper solution, you have 0.05 mole of copper deposited, which also corresponds to 3.2 gram of copper. So thank you for watching.